All right, guys, we're going to start one of my favorite chapters, all about quadratics and their functions, aka graphs, and their equations and how we solve them. It's a lot like our linear functions chapter, where we talked about 3 different forms of a line and like how to graph each form and all that fun stuff. So we're going to do the same thing, but with these fun new graphs called quadratics, our super fun new functions. So in our table of contents here, today we're really just going to sort of look at the graph and talk about its unique features and important points that we should look out for when we're looking at the picture. So we're going to call this Intro to Quadratics. And we're just going to do that on 103. And then each day after this, we will talk about each different form like we did for a line. We're going to do that for this, and then, yeah, it'll be a good time. Okay. So hopefully, if we went through our Desmos today together, we pointed out some of these important features and unique features of our graph. So a quadratic graph always has this sort of N shape or U shape if it's pointing up. And so, like when we were talking about linear equations, one of our most important points of a linear equation was the y-intercept. A quadratic also has a y-intercept. It's sort of less important, but it is still helpful. And like this y-intercept is at 0, -6. Now, we don't talk about it very often with linear equations, but not only do we have a y-intercept, but we also have x-intercepts with lines. A quadratic sometimes has 2 x-intercepts, so we can also take a look at those. So we have an x-intercept here and here, one at 2, 0, and one at 6, 0. Now, kind of after we talk about the intercepts, there are some other unique features. The graph itself, the shape of it, because it's not a line, it gets a unique name. The name of the shape of our graph is a parabola. So a lot of the times you hear people use quadratics and parabolas interchangeably because we kind of mean the same thing. A quadratic graph has the shape of a parabola, and so they kind of mean the same thing. Now, when we are talking about a parabola, one of the key points, one of the main things is this top point, or if the graph is going up, this bottom point. So at the very tippy top here, and it's also sort of where the graph changes directions, right? This graph was going up, 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 got to its highest point, and now it's like, nope, now I'm going down. So that point is super duper important, and it is called our vertex. We kind of had a vertex when we were graphing our absolute value functions. Those graphs always looked like a V and came to a point, and that point was also called the vertex. So our vertex here is at 4, 2. And sometimes a vertex can be the highest point, so a maximum, or it could be the lowest point, so a minimum. I'm not going to put minimum there because that would be confusing. Like this is a maximum, so we just want to call it maximum. Now, also at that spot, we have this line that we can draw straight up and down that really cuts our graph completely in half equally. And so that line, because I have the same thing on both sides, is called a line of symmetry, because if I'm symmetrical, then I'm the same on both sides, or kind of a line of reflection, some people will call it, because whatever I have on one side, I have on the other. It all flips over, kind of like a mirror. Some people will also call it, instead of a line of symmetry, an axis of symmetry, because it's not the x-axis or the y-axis, but it's kind of like that. Like it's a spot that's pretty important that cuts a thing in half. And so, yeah, I think I want to maybe leave it there, and we will do some of these things underneath, which is the same stuff we just talked about. So the shape overall of our graph is called a parabola. And so if we open this one up here, you know, we could just have a table of values where we go plot these points. So if I look at this first graph, I would plot the point 0, 1, then 1, -2, 2, -3, 3, -2, and 4, 1. Now, a couple of things that we can kind of see in our table if we look at the y values. We can see it going down, 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 and then coming back up. Also, I can tell that this is sort of the middle because I have the same numbers on either side of that. So my table also sort of shows me that I have this symmetrical thing going on, and we have sort of this bottom point. So in this case here, my parabola is pointing up, and like the vertex is at the bottom. So that's kind of fun. We always kind of want to look at our arrows. And so because my arrows are up, that's why we go with up. You know, or my parabola could be pointing down. So if we go to graph this guy right here, we got -2, -5. Oh my gosh, I did that backwards. Dyslexia. -5, -2. Boop, boop. -4, 1. -3, 1, 2, 3, 2. -2, 1. Open, then here we go again. And then -1, -2. So again, I can see that I'm symmetrical. I have the same things on both sides of that middle number, which is super nice. And my graph will continue to go down this way and continue to go down that way. And because my arrows are pointing down, that's why we call this a downward pointing parabola. Okay, so our parabola can point up, or our parabola can point down, and I'm just always thinking about which way the arrows are going. Okay, another important feature of a parabola is that axis of symmetry, or a line of symmetry like we were talking about. It's this line that splits my graph equally in half. Okay, so parabolas are symmetric about a central line called a axis of symmetry, or a line of symmetry. The axis of symmetry cuts our parabola in half vertically, so straight up and down, through the equation of the form x equals some number. Just whatever number it's going through. Okay, so we'll kind of try that down here. So if I see this parabola right here, I just want to find that middle spot. Also, kind of your axis of symmetry is on your vertex. So really, I sort of just find my vertex, and then I go straight up and down. So because this is going straight up and down and touching the x-axis at 0, my axis of symmetry line is at x equals 0. Now for this one here, I can see that the vertex, this top point, is right there. And so I would draw my line straight up and down through that point. And this is touching my x-axis at -2. So my axis of symmetry is at x equals -2. And then last but not least here, I want to cut this parabola right in half. So right there. And then if I look at where that's touching the x-axis, it's touching at 3. And so my line of symmetry is x equals 3. A lot of students will ask me, can your parabola point sideways? And the answer is yes, but we're not going to do any of those this year. You'll get to do those in Algebra 2. So Super fun when our parabolas point sideways, but we're not going to do those yet. We're just dealing with pointing up parabolas and pointing down parabolas. Okay, so then that last key feature of our parabola is kind of the most important one, and that is our vertex, which sometimes my vertex is a maximum and sometimes my vertex is a minimum. It just depends on which way my graph is pointing. Okay, so like I was showing you guys on the last one, we were talking about on the last one, the axis of symmetry goes through my parabola at one point, and that is at the vertex point. That is right where the graph decides to change direction. And so that is definitely where the graph is split in half equally, because if I was going up and I'm like, whoop, nope, now I'm going down, that's where I changed. And so we have the same thing on both sides. Okay, so if my vertex is a maximum, then that means it is the highest point on the graph. It's like the tippy top of the graph. It's the tippy top of the mountain. If my vertex is a minimum, then that means it's the lowest point on the graph. So it's the very bottom. There is no graph underneath it. Everything else is coming up from it. Okay, so the vertex is a point, and it also helps me to figure out my range of values, because we always want to be thinking about domain and range. And so the range will always be y is less than a number, or y is greater than a number. So it'll be less than a number if my graph is pointing down, which I think that makes sense. It'll be greater than a number if my graph is pointing up, which I think makes sense, because like less is going down and greater is going up. Okay. So if we look at these parabolas right here, I can see that my vertex, this spot right here where we change direction, is at 0, 2. When I think about domain and range, domain are the x values, and x goes left and right. This graph is pointing to the left and to the right, so eventually it will get to all of my x values, so like all real numbers. However, because this graph, when I'm thinking about range, and range is up and down, this graph is only going up. So because it's going up, 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 that must mean there is a lowest point. And so my range will always be greater than or equal to, because I'm going up, that's why greater than, this bottom value. And the bottom value right there is 2. So like whatever my vertex y value is just pops in for the range. So that's super nice. Now looking at this graph here, I can see that my vertex is at this spot right here. That's where the graph changes direction. I also want to say that this right here is a minimum point, because it was the lowest. So when I look at this vertex, it is located at -2, 0. And because it's the tippy top of the mountain, that makes it a maximum, because it's the highest point on the graph. And so again, when I think about my domain and range, these arrows are pointing left and right, which means they're going to go on forever left and right, which means my domain will be all real numbers. And fun fact, your domain will always be all real numbers for parabolas. The range, however, is always restricted. Because this parabola only goes down, that means it had to have this highest point. So because it has a highest point and it's going down, 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 the y values are going to get smaller, 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 or less than or equal to this topmost value, which was at 0. Okay, so these are the basics and like the things that we need to keep in mind going forward every single time I graph, no matter how I graph. These are kind of our most important features: the vertex, the line of symmetry, and then also understanding that the shape is a U shape or an N shape and not a pointy V shape. All right, I'll see you on the next one.